All right, great. So I want to talk about nutrition and immune function. I'm going to share my screen and with slides in just a second, but the objective of this presentation is really for people to gain more confidence in their bodies. I think what we watched during the last 3 years is people beginning to feel like they're frail. Like any common cold or flu virus that comes along, my gosh, it could take you out. And it certainly does have that capacity for some people, but the vast majority of us have really incredible immune systems. And with a little bit of help doing the right things, you can optimize your immune function and protect yourself against disease. So let's go on ahead and share the screen with the slides here. And so far, so good. Everything's working. This is great. All right. So I always like to start with some basics and foundational information that I think most people know and don't know, rather. And I think that ignorance, as in just lack of knowledge, is one of the things that makes people feel insecure about their health and possibly make bad decisions about what to do about their health. So believe it or not, the ancient Greeks knew about immunity. And doctors were writing about people who recovered from the plague and then became immune for life. The earliest attempt to induce immunity took place in 10th century China. Healthy people were exposed to smallpox under the skin or in the nasal passages. It was duplicated during the Ottoman Empire with limited success. And then in 1796, Edward Jenner discovered inoculation for smallpox. In the 19th century, Robert Koch discovered that infectious diseases were caused by microorganisms or bacteria and could be transmitted from one animal to another. And then I think we're all familiar with the story. Pasteur accidentally inoculated 8 chickens with chicken cholera bacillus, and he called his treatment vaccination. And all of this combined established the germ theory of disease. By the end of the 19th century, what we knew about all of this were that germs and bacteria cause disease, immunity to infection could be induced via a vaccine, and regulation of this process was really important to prevent antibodies from attacking self. So we'll talk about regulation of the immune system in just a second here. But an important note here is that germs and bacteria do cause disease, but the potential to cause disease is influenced by the health of the host. So the fact that something is circulating out there, which it does every cold and flu season, doesn't mean that you're going to get it. And even if you get it, doesn't mean that it's going to be devastating. So the immune system has evolved over millions of years in order to develop defense mechanisms to protect humans from foreign invaders. And there are 3 key properties that we're going to discuss. One is the highly diverse repertoire of cells that can recognize an infinite number of pathogens, the memory to enable rapid recall and response, and tolerance to avoid damage to cells and tissues of the body. In other words, your immune system is so sophisticated that it's supposed to recognize something that is not supposed to be in your body versus cells of the body. What this does, all of this, is it protects us from disease-causing microorganisms that get into the body, foreign tissue, organs, or cells that may have been transplanted. This is why transplant patients have to take immunosuppressant drugs, and the body's own cells that may have become cancerous. It is an amazingly complex system. It is far more sophisticated than any of the most powerful computers that we have on the planet right now. It can recognize and remember millions of different pathogens, produce fluids and cells targeted specifically to these pathogens, and eliminate them. And the 4 main types of invaders that we'll talk about briefly are bacteria, parasites, fungi, and viruses, with a particular emphasis on viruses because that is what people are most concerned about right now. So immune function and dysfunction. When functioning normally, the immune system knows the difference between self and not self. In fact, the immune cells normally leave cells alone that carry a distinctive self-marker molecule, and it attacks only those that identify themselves as non-self. Anything that triggers an immune response is called an antigen. Foreign invader antigens carry marker molecules that identify themselves as non-self. When the immune system mistakes self for non-self and launches an attack, the result is autoimmune disease. When the immune system responds to a normally harmless substance, the result is allergy. The antigen that causes allergic reaction is called an allergen. So both allergy and autoimmune represent a misfunction or malfunction of the immune system. which can be regulated and fixed. That will not be part of our discussion today. We're going to deal with the other side of it, which is when immune function is not up to where it should be and what you can do to change that. So there are three main forms of immunity. One is acquired, another is innate, and three is adaptive. All right, so acquired immunity, we'll start there. So some antibodies cross the placenta and enter the bloodstream of the fetus. Newborn infants acquire some temporary immunity from antibodies passed on from the mother through breast milk until the immune system develops. Immunity develops throughout life via a growing number of memory T and B cells after infection. In other words, something important to understand about this is if you never get sick, you can never develop a strong immune system. So I've always told people, obviously, we don't wish sickness on anybody, and some sickness is serious, and we don't wish that on anybody at all. But the other side of that is constantly trying to avoid being sick is like avoiding the gym because it's uncomfortable, but that's the only way you build muscles. You have to have illness in order to build a strong immune system. Immunity can be acquired without exposure to a pathogen. We call that immunization, right? Most immunizations involve injection of a bacteria or viruses that have been inactivated or weakened, and then these induce an immune response but don't result in full expression of the disease. So, for example, when you receive a flu vaccine, you're not supposed to get full-blown flu. The innate immune system is an ancient defense system that we inherited from invertebrates. It's comprised of cells and proteins that are always ready to fight microbes and infection. They kill pathogens directly or slow down infection until the adaptive immune system can become engaged. They're immediately available to fight many pathogens, but they're not specific to a particular pathogen, and you don't get lifetime immunity as a result of this. The adaptive immune system is a more recently evolved system of immune responses involving B and T cell lymphocytes. Immune responses by these cells are based on antigen recognition. This is found only in vertebrates. Antibodies are proteins that bind to microorganisms and neutralize their activity. The production of an antibody to a particular pathogen is an adaptive immune response. That's why we call it adaptive immunity. Adaptive immunity takes time to develop and activate. It is specific to the pathogen, and it confers lifetime immunity. This is in contrast to innate immunity, which is ready all the time. It's the line of first defense. It can neutralize things a little bit until you can develop an antibody. Now, when we talk about lifetime antibody, it's one interesting thing I want to point out here is that it's true that antibody response wanes over, antibody counts wane over time. But an interesting thing happened in 2020 with a researcher in the UK who took plasma samples that were part of a prospective study and exposed them to SARS-CoV-2 in a petri dish. And she found that the blood samples had immune cells that were able to neutralize SARS-CoV-2, even though it hadn't been encountered before. So our immune system is so sophisticated, it can even say, listen, this isn't entirely like what I responded to last time, but it's close enough that I should probably get involved and do something about it, all right? So we have a lot of protections in place. The adaptive and innate immune systems work together. The cells of the adaptive and innate immune system travel to the site of infection and injury, and they want to clean up infection and dead tissue. Inflammation triggers this response, and inflammation is beneficial, but not when it becomes chronic. So people think that all inflammation is bad, which is why everybody wants to suppress a fever as soon as it started, but I'm going to show you that that's really not a very good idea. Now, we also have some innate barrier systems or external defenses. This is non-specific immunity. It protects against irritants or abnormal substances that threaten our internal environment. And so some of these areas are like skin and mucous membranes. These are mechanical barriers that keep stuff from getting into your system, tears and mucus, stomach acid, and the phagocytosis of bacteria. The mucosa covers respiratory, digestive, urogenital tracts, eye conjunctiva, inner ear, exocrine glands, mammary glands, stomach, liver, pancreas, and the role is to protect the surfaces against pathogens. In healthy adults, something called mucosa-associated lymphoid tissue, or MALT, contains 80% of all immune cells in the body. And this is another way that you repel pathogens when they're trying to get into your system. So, for example, a cold virus gets into your nose. That doesn't necessarily mean that it's going to make you sick, because the mucus in your nose is supposed to, when it's working well, try to capture and expel critters that don't belong there. A healthy microbiome helps to prevent inflammation, generates an anti-inflammatory reaction in the GI tract, protects epithelial cells from pathogens. If that beneficial bacteria is compromised, the immune system becomes compromised. And unfortunately, life is filled with ways in which we compromise our immune systems, and that's our microbiome, which compromises our immune system. And that's everything from the overprescribing of antibiotics to the eating of poor diets, obesity, all that sort of thing. So many, many ways in which this gets disrupted. And it's a fairly new science. We really didn't pay much attention to this when I got into the healthcare business almost 30 years ago. When the gut bacteria barrier is intact, antigens are blocked from entering the bloodstream and pathogens are eliminated before they get in. But when the barrier breaks down, things that shouldn't be getting into the bloodstream get in, and that's everything from partially digested food proteins that can lead to autoimmune disease, or antigens that can cause allergic responses, and of course, viruses and pathogens that would normally be expelled. So we'll talk about this a little bit later, but if you have a compromised gut microbiome, fixing it is a really good idea because you can't restore normal immune function without doing that. Mast cells protect the internal surfaces of the body against pathogens. You find these in the lungs, the skin, tongue, linings of the nose, and intestinal tract. They're involved in symptoms of allergy. So they're also involved in eliminating parasitic worms. And there's a hypothesis that since people in developed countries no longer are exposed to parasites as much, then the mast cells stay busy by responding to other substances, which may be why we see a bigger propensity for allergy right now than we used to. It's a hypothesis. I'm throwing it out there because it's interesting and perhaps worth considering, but I don't think that we are stuck with allergies. There are a lot of things you can do to resolve allergies in spite of this. Natural killer cells are lymphocytes filled with chemicals that respond to all kinds of pathogens, including cancer cells, by the way. They're found in the lymph nodes, the spleen, the bone marrow. They circulate in the bloodstream. They attack cells carrying foreign or abnormal molecules on the surface, and they attack and kill viruses. They often are hidden because they grow inside infected cells, and then they can spill small fragments in cell membranes. B lymphocytes are the most important cells of the adaptive immune system. B lymphocytes mature in the bone marrow. They secrete proteins called antibodies. Those are the very disease-specific white blood cells or immune cells that can go after viruses. They fight specific pathogens. Each B cell is programmed to make one specific antibody. There's an antibody for this year's circulating cold virus. There's an antibody for dozens and dozens of flu viruses and all kinds of other crud that has gotten into your body. I'm 66 years old, and believe me, that a lot of crud has gotten into a body this age and been neutralized by antibodies. Once activated by contact with a pathogen, they form plasma cells that produce antibodies. Those neutralize the pathogens until other cells can remove them. And some of those other cells would be like macrophages. They act like little Pac-Men. They come in and they clean up the debris and garbage. It's like taking out the trash in your system. After an infection, memory B cells circulate in order to generate a faster response to the same antigen if it infects the body again. So theoretically, what happens in a healthy person is you might get exposed to the same virus numbers of times. And each time, because viruses mutate. And by the way, they don't generally want to kill their hosts, because if they do, they have no place to live, right? But as viruses mutate, you may be exposed to another strain, but even though it's not entirely exactly like the first strain, your antibodies will recognize enough of it to go to the rescue. And most of the time in a healthy person, keep you from getting sick again. Your T lymphocytes mature in the thymus. They attack microbes inside cells that antibodies can't get to. They also fight specific pathogens. They can assist other immune cells or attack directly. And then after infection, they remain to provide faster reaction in the event of an infection with the same pathogen once again. There are three types of lymphocytes: helper T cells, which help the B cells, and help the macrophages to kill microbes and ingest them, that Pac-Man thing that I was talking about. Cytotoxic T lymphocytes directly kill infected cells, and regulatory T cells, which control immune response and prevent overreaction and autoimmunity. And here's what I mean by this, and it's a very important thing to understand. When your immune system mounts a defense against an incoming pathogen, that's normal. What's supposed to happen is once that pathogen is neutralized, the immune system says, okay, we're done now, so we can lower the numbers of all of these immune cells that are circulating. So it works on a feedback loop like your furnace. So if you have your HVAC system set at 70 degrees, as soon as it dips a little bit below that temperature in your house, the thermostat will kick on the furnace to bring it back up to 70 degrees and then kick off as soon as it reaches that threshold. And that's the way your immune system works. And when you end up with autoimmune disease, that's the immune system not knowing how to properly shut itself off. It can be taught to do that in many cases, but like I said, we'll focus more on how we build to the place where your immune system is more responsive to pathogens coming in. So here's what we have with the adaptive immune response. First, recognition. Something is in the body that shouldn't be there. Activation, antibody producing cells, effector T lymphocytes. The effector phase, get rid of those antigens. Decline, apoptosis, cell death. Memory, some antibodies survive. All right, so that's the system. Now let's talk about the lymph nodes and the lymph system a little bit. Similar to plasma in the veins, it's about 90% water, 10% solutes like proteins and cellular waste products. It can also contain bacteria from diseased tissues and white blood cells that fight these pathogens. Lymph is transported through the body, through the lymph vessels, which are stimulated by a skeletal muscle pump. And that is why sometimes massage will stimulate lymphatic function if your lymph vessels are not functioning properly. Contractions of skeletal muscles constrict the vessels to push the fluid forward and through the system. The nodes are small and kidney-shaped. The highest concentration of them is in the armpit and in the groin. The outside capsule is made of really fibrous, dense fibrous connective tissue, and the inside is filled with tissue containing lymphocytes and macrophages. In other words, your lymph nodes house a lot of immune functions. That's why you have to be very careful about how many of these little critters you allow to have taken out of your body. The nodes filter debris or cells, and lymph macrophages and lymphocytes attack and kill microbes. The filtered lymph carried out of the nodes toward the lymphatic ducts. The tonsils are actually lymphatic nodules. There are 5 tonsils, which contain B and T cells, which protect the body from inhaled or ingested substances. They often become inflamed in response to an infection. I posted an article, a very long article in our library a few years ago about the inadvisability of removing tonsils unless you really have to. When I was a kid, by virtue of my age, it was common for all children to have their tonsils taken out at some point in time. And so both my sister and I had our tonsils taken out. The sentiment is changing a little bit. And there are times clearly when they become so inflamed and infected that you have to take them out. But there is a growing realization that these were not put into our bodies. This idea that there are parts of the body that are just disposable. And this is what causes people to have their gallbladders taken out as soon as they have any gallbladder inflammation. And gosh, you don't need your appendix. And well, the research is showing increasingly that we ought to be a whole lot more conservative about taking out body parts, including the tonsils. So my immune system is compromised just a tiny bit. There are ways to compensate for it by doing other things really, really right. But because my tonsils were taken out, there's one line of defense that I don't have. And many of you may be in the same situation. The Peyer's patches are found in the ileum of the small intestine. They contain T and B cells that monitor the contents of your intestines for pathogens and then trigger an immune response if they detect anything there. The spleen is another body part that's taken out as part of the immune system, sometimes a little bit more often than it should be. It filters blood, removes damaged blood cells, and then the macrophages, those Pac-Man type critters I talked about before, digest and recycle hemoglobin. The spleen stores platelets to be released in response to blood loss. And again, you have a huge reservoir of immune cells in your spleen. And again, if you're watching this and you've had your gallbladder taken out, you've had your appendix taken out, and your tonsils and your spleen, and believe me, we see this kind of thing often with clients who consult with us. That doesn't mean that you're doomed. It just means that you have to work a little bit harder at other things in order to stay healthy. And then one last thing, the thymus is a small triangular organ in the back of the sternum, which produces and trains T cells during fetal development throughout childhood. So by puberty, the immune system is supposed to be mature, and the role of the thymus lessens and becomes a little bit more inactive. So if a child, optimally, a child who's vaginally born, breastfed, and eats a great diet, doesn't become overweight, and can maintain all of his or her body parts, should reach adulthood with a really well-functioning immune system that has been trained throughout the child's lifetime by getting sick and recovering and getting sick and recovering to the place where the exposure to more and even more pathogenic antigens should not be such a problem in most cases. All right, so once an antigen is discovered, the lymphocytes return to the lymph nodes with a description of the antigen, and this it's like a blueprint. This stimulates T lymphocytes and B lymphocytes to multiply, and that stimulates the production of antibodies. It takes 4 to 6 days to create an antibody to a new antigen. And so sometimes the innate immune system can neutralize something and make it go away before the adaptive immune system has to get involved. But if not, the adaptive system will eventually get involved. And the reason why you might be sick for a while is because your body's busy producing the antibodies that are required to get rid of whatever crud that you have. All right, so let's talk a little bit about inflammation, which is an important part of the body's immune system. It assists in healing injuries, wounds, damaged tissue, defends against viruses and bacteria. If you were not capable of generating inflammation, wounds and sores would not heal, and infections would get worse and cause death. The problem is uncontrolled and chronic inflammation, which plays a role in the development of chronic disease. So your inflammatory markers are made up of complex fatty acids. Leukotrienes and prostaglandins are made from a precursor, which is arachidonic acid. And we'll talk about the source of arachidonic acid and how you can avoid chronic inflammation by paying attention to your diet in a little bit here. So these inflammatory markers are responsible for a lot of the symptoms that we associate with inflammation. So you need inflammation. It facilitates the delivery of immune cells to the site of infection or injury in order to destroy pathogens, stimulates local blood clotting. It's a physical barrier to spreading the infection in the bloodstream and promotes tissue repair. During the inflammatory process, and as part of addressing injury or a pathogen, the surrounding tissue is damaged and the tissues are repaired after the threat's neutralized. So again, you have this feedback loop like the thermostat on your system, on your HVAC system, that the inflammation is supposed to go away. Inflammation is always supposed to be transitory, all right? And memory lymphocytes remain in case the same invader appears again. The response time will be faster. But the bottom line is that it's not inflammation that's the problem, it's chronic inflammation that's the problem. So acute inflammation is generally caused by bacteria or viruses or an injury. The onset's rapid, it lasts for a few days. If it turns into a chronic condition, it usually is because the underlying health of the individual was compromised before the injury or infection. Chronic inflammation is caused by serial bacterial infections. So we see this all the time. People who have UTIs 5 times a year and take antibiotics, or chronic sinus infections and that sort of thing. Viruses, irritants like smoking, autoimmune disease, fat cells. The onset is slow and cumulative, can last for months, years, or decades. And the outcomes include anything ranging from tissue death to premature death of the individual. So it's chronic inflammation you worry about. So persistent inflammation really is too much of something that we would normally consider a good thing. Inflammatory disease is an exaggeration of the normal immune inflammation response. The body miscalculates, mounts an aggressive response when there's no invader, there's no injury. It's not warranted, and the number of immune cells recruited is even larger than it would be for a normal threat. more prostaglandins are produced, more blood vessels dilate, more redness and swelling, and more pain. And this results in more white blood cells and more damage to the tissue. Since the activity never stops, the body never has a chance to settle down and heal. That's why, and then chronic inflammation is a common denominator, along with excess weight and obesity, for almost any disease that you don't want to get. So this brings us to fever, which is triggered in response to infection. It raises the internal temperature out of the normal range. It speeds up the body's response to infection and slows or stops the replication of the pathogen. So lowering a fever is usually not a good idea. I've written reference papers on this as well. It can slow the process of healing. And we've reached the place where people know so little about the function of their body, and they're so terrified anytime something happens, any type of illness, whatever, that they think that you automatically want to reduce the fever because it's dangerous to have a high fever. And it is dangerous if the fever goes too high, but when you reduce the fever, your body is compromised in its ability to recover from whatever crud you have. So infections include everything from the common cold, chronic hepatitis, HIV. The most common are bacteria, viruses, sometimes parasites, although those are overdiagnosed in the United States. Each uses a different method to cause infection, which is addressed by your specific immune responses, which I've covered before. All viruses, plus some bacteria and parasites, must enter the cells of the body to survive. And this goes back to something I said earlier that you need to repeat to yourself till you're not panicked about viruses anymore. And that is that unless you are severely compromised, viruses don't want to kill you because then they have no place to live. All right. Infected cells display pieces of the invading microbes on their surfaces. That's how the natural killer cells know to go after them. And then antibodies assist by attaching to and clearing viruses before they have a chance to get worse. Most bacteria live in the spaces between the cells. They're pretty easy for antibodies to find. Pathogens trying to get into the body are countered by the barrier systems, which I described earlier, like the skin is a barrier system, the mucous membranes are a barrier system. By the way, sneezing and coughing are attempts to get microbes out of the respiratory system. And so you will have to be careful about how much suppression you use there as well. Underneath the epithelial layer are macrophages, B cells, T cells, ready to go all the time to go after foreign invaders. And then the innate immune system kicks in, and eventually the adaptive system kicks in. And by the way, you have other things too. So if you have a runny nose and a lot of mucus, that's your body saying, you know what, we have to get rid of this crud. And so the only way to do that is to trap the crud in more and more mucus. That's why you're blowing your nose all the time when you have a cold. The stomach contains strong stomach acid that destroys pathogens that are consumed in food. And by the way, I've written papers on this, taking proton pump inhibitors, all the purple pills, because everybody's eating terrible diets that cause such discomfort. One of the leading causes of food poisoning, illness resulting from food poisoning, is people taking so many acid suppressors so that they can continue their poor dietary habits. You don't have to worry about the skin unless you have some type of breach, like a large cut or injury, that sort of thing. That's how pathogens get into the skin. But the skin does a pretty good job of keeping things out as well. So your general immunity can be strong or weak, short-lived or long-lasting, depending on the type of antigen presented, the amount of it, and the route by which it enters your system. Immunity can be influenced by genes. So when faced with the same antigen, some people have a strong immune response, some a weaker response, and some are incapable of responding. But the bottom line is whatever your immune system is doing right now, whatever its state is right now, it can be improved through diet and lifestyle habits and other means. So if you're one of those people, we encounter them all the time, who says, oh my gosh, every year if there's something traveling around, I get it. I usually get it 3 times. And if you're one of those people who just dreads getting the flu because the last time you had it, you were down for 3 weeks, that doesn't have to be the way it is forever. You can fix it. A person who's encountered an antigen can respond quickly to a second encounter without so much time lapse. And the second response can be stronger. Hypersensitivity is when you get an abnormal reaction. Autoimmunity is when you get a reaction against self, the immune system's out of control. And chronic inflammation is immune-mediated inflammatory disease. So You don't want to have a hyperactive immune system, and you don't want to have an underactive immune system. And just like everything else, your computers, for example, when you don't have viruses on your computers and you shut them down and get the updates and all that sort of thing, you just take it for granted that your computer is pretty much going to work every day. And your immune system can do that too if you'll just help it a little bit. So in summary, now we're going to get on to the really juicy stuff here. There are 4 general functions of the immune system. Create a barrier to prevent pathogens from entering the body. Identify them if somehow a barrier is breached. Eliminate pathogens. Generate immunological memory. The body's immune system, as I mentioned, carefully calibrated to mount very specific immune responses to foreign invaders. In healthy humans, the immune system knows the difference between self and non-self. It knows how to switch itself off. It's affected by many things, a little bit of genes, a whole lot of exposure to pathogens, diet and lifestyle choices, and that sort of thing. And so where your genetic susceptibility comes in, I'll use myself as an example. I come from a family of people where women have autoimmune diseases. I'm the first woman on my mother's side of the family who doesn't have autoimmune diseases. My sister has them, my mother had them, my grandmother had them. All right, I've taken care of myself differently because I am well aware of my genetic susceptibility, and I do not want to end up with rheumatoid arthritis or something like that. So if you are genetically susceptible, note to self, take extra good care of yourself so that this doesn't happen to you. All right, so let's go on to talk about things to do. Humans are constantly infected with multiple viral agents. You cannot avoid it. We're exposed to up to 1 billion new viral particles every single day. So if you can't avoid it, I mean, even if you stay inside your house, you can't avoid it. Better to work on protecting yourself. And that is building immune function. And the immune system and its function are based on the health and habits of the human in which the immune system lives. All right, so some basics. Nutritional inadequacy increases the susceptibility to infection and can lead to more severe infection. Now, I'm not talking about inadequacy like calorie deficiency, although that would certainly make a person more susceptible to illness, obviously. I'm referring to poor diets that don't include enough densely nutritious foods and plants. So most people eat more than enough calories if you've been out and looked around lately. The problem is wrong choices, right? And this may explain why older people and obese people are more likely to have severe flu, including COVID, because most people are not eating so well who are younger, and they don't magically change their habits when they retire and enter older age, right? So that's the problem. Optimal nutrition provides overall health and a healthy gut microbiome, which regulates the immune system. The microbiome is part of the thermostat program. So here are the things you want to pay attention to. The food you eat. I wrote a book called Food Over Medicine, and there are a lot of different ways you can categorize food, but I'll just give you one idea here that I think is really important. You can have food, I think, that you should definitely stay away from. Oils, they're calorie dense. Most people can't afford to eat too many calories, right? That's why we have an epidemic of obesity. Dairy, I think it's the only food group that warrants some consideration for elimination. So we have foods, category A, don't eat. Then we have middle category, I call it the no harm, no foul. So pretzels and crackers, I don't really see those causing a lot of problems for anybody. I never saw anybody die from eating too many crackers. But there is absolutely nothing healing about eating crackers. That does not build a strong body. So then you get to the third category, which is the food as medicine, right? These are the foods you want to eat. So I instruct our clients to go to the grocery store and start looking at this as if it's the drugstore. All right, there's a class of fruits of drugs called stone fruits. I'm going to get some of those. There's a class of drugs called root vegetables. I'm for sure going to get some of those. There's a class of drugs called leafy greens. I want to make sure I get some of those, right? So think of really focusing on food as medicine. The gut microbiome, medications. I mean, I mentioned before, we overuse antibiotics like crazy. Smoking, alcohol consumption, weight, BMI, a risk factor for everything. Age is a factor, but there's a lot you can do to make it not as much of a factor. Stress, physical fitness, even the time of day can influence your vulnerability. comorbidities, frailty, and vaccination. So immunosenescence is the lowering of immune response based on aging. And the factors are you decrease production of cells in the bone marrow, which is where a lot of your immune cells come from, decreased output of naive T cells, which decreases the ability to respond to new antigens, less cytotoxicity of immune cells. So older people become more susceptible to viral infections. Studies show that frailty results in less robust immune response after vaccination and increased post-vaccination flu. And by the way, the number one reason why people end up in nursing homes is not because they aspire to be there. I've never met anybody whose goal was to end up in a nursing home, right? The reason they end up there is frailty. They're incapable of living by themselves. So you want to build a strong body now so that you can stay independent for your whole life. I'm in my forever house. I intend to live here until I die, but that is dependent on working very hard right now to make sure that I can do that. Aging increases the concentration of inflammatory markers in the blood unless you do something deliberately to keep that from happening. Older and more frail people are more likely to develop higher inflammatory response to infection. It's referred to as a cytokine storm. And you can reverse this with better diet and hydration and exercise and sunlight and probiotics.